this series of courses, we will cover everything about dust collector filter bag and pulse jet bag filter. Course 1. Quick introduction. A fabric filter unit consists of one or more isolated compartments containing rows of fabric bags in the form of round, flat, or shaped tubes, or pleated cartridges. Particle-laden gas passes up, usually, along the surface of the bags, then radially through the fabric. Particles are retained on the upstream face of the bags, and the cleaned gas stream is vented to the atmosphere. The filter is operated cyclically, alternating between relatively long periods of filtering and short periods of cleaning. During cleaning, dust that has accumulated on the bags is removed from the fabric surface and deposited in a hopper for disposal. This course consists of air pollution, type of air pollution control equipment, bag filters basic operating principles, bag filters classification based on how the fabric is cleaned, factors governing selection of type of filter. What is air to cloth ratio? What is can velocity? Evaluation of the can velocity effect on a bag filter. Types of bags and their design temperature. Filter fabric selection. Types of bag cleaning. It is divided into 3 types. 1. Shaking filter. 2. Reverse air filter. 3. Pulse jet filter. Bag filter fundamentals. Fabric filter control system. Air pollution can be defined as the introduction into the atmosphere of chemicals, particulates, or biological matters that cause discomfort, disease, or death to humans, damage other living organisms such as food crops, or damage the natural environment, or built environment. Basic concept. Particulate matter separation. Subdivided into 1. Scrubbing. 2. Filtration. 3. Electrostatic precipitator. 4. Mechanical dust collection, and bag filters. 5. Dust suppression. Type of air pollution control equipment. Constant efficiency. These are the methods we use. Cyclones or multi-cyclones. Scrubbers. Electrostatic precipitators. Constant emission. Always use. Bag filters. Bag filters. Basic operating principles. Fabric filter pulse clean. General design. Consists of 1. Weather enclosure. 2. Top box. 3. Outlet damper. 4. Outlet duct. 5. Inlet duct. 6. Casing. 7. Gas and dust distribution. 8. Inlet damper. 9. Dust removal systems. 10. Insulation. 11. Support. 12. Bags and cages. 13. Hopper. 14. Access. Bag houses and filters. Dust particles are retained on the surface of the filter medium and the cleaned air passes through the filter medium and flows into the clean gas chamber or duct. Dust collection hopper, or tray with material discharge screw, or scraper chain conveyor. Top-down flow in filter housing. Insulation to avoid undershooting of dew point, hot gas version. Dew point can be defined. The minimum temperature flue gas temperature, below which the moisture settles on the bags, and particle adhesion takes place. Basic operating principles. Watch this video explaining operating principles for pulse bag filter, as it is one of the most important operating principles. Solids laden air or gases enter the unit at the hopper or housing inlet. Air passes through the filter media. Solids are retained, on the filter media surface. Cleaning cycle consists of, a momentary blast of 90 to 100 pounds per square inch gauge compressed air. 1. Momentarily taking a row of cartridges off stream, through pressure reversal. 2. Flexing filter cartridges. 3. Solids are released to fall towards hopper, and through rotary valve, or other discharge equipment. Watch another video explaining, operating principles for pulse bag filter. Dust-laden air succession, init the bag filter with velocity. Bags inside filter, the air and dust particles are separate. Filtered dust-free air is sent to the environment. Reverse Puel's jet flow clears the bags at pre-programmed intervals. Dust particles accumulated on bags are get detached from bags, and fall into hopper after pulse jet cycle. Bag filters classification based on, how the fabric is cleaned. 1. Shaking. 2. Compressed air. 3. Reverse air. Bag filter basics. In an industrial system of gas cleaning, the fabric is media made into either an envelope or a tube. These envelopes or tubes are called the bags, made of woven or felted fabric, as a filter medium, and a housing of these is called bag filter or baghouses. Factors governing selection of type of filter. 1. Inlet dust load in milligram per normal meter cubed. 2. Gas volume in normal meter cubed per hour. 3. Gas temperature. 4. Nature of pollutant, gaseous and particulate. 5. Properties of dust, physical as density, size fraction, temperature, wettability. 6. Properties of gas, physical, chemical as nature, acidic, alkaline, moisture content critical. 7. Nuisance value and recovery value of both dust and gas. 8. Outlet emission requirements and efficiency required. 9. Space availability. 10. Economics, budget, fund availability, return on investment. What is air-to-cloth ratio? Air-to-cloth ratio equals total volume of gas handled by the bag filter, cubic meter per minute, divided by total filtration area provided in the bag filter, meter square, equals cubic meter per minute, multiplied by meter square equals meter per minute, equals or greater than velocity unit. Hence also called filtration velocity, and is actually the velocity at which the dust-laden gases travel across the filter element. The more critical the dust, fine, light, sticky, non-agglomerating, abrasive or higher the dust loading, the larger is the filtration area provided, lower is the air-to-cloth ratio maintained. What is can velocity? Can velocity equals velocity at which the gas travels upwards, across the cross-section of the bag filter equals total volume of gas, or air, handled by the bag filter, cubic meter per minute, divided by cross-sectional area of bag filter casing, meter square. Important notice. This is an important aspect, and has to be restricted especially for fine, light, and non-agglomerating dust. Lime, carbon black are typical examples, as otherwise the dust may remain in a fluidized state in the bag filter, and not get discharged from the unit at all. Can velocity. The theoretical speed of dust-laden air as it passes upward between the filter bags. The formula for calculating can velocity is as follows. The square area of the bag house, length multiplied by width, minus the area occupied by the bottom of the bags, the sum of the areas of the number of bags, divided into the volume of air in actual cubic feet per minute. This formula yields a velocity in feet per minute. The bottom of a stack lean 6-inch diameter bag is 5-inch, 7-inch to 8-inch. See this example to calculate bag house can velocity. Evaluation of the can velocity effect on a bag filter. Highlights. Can velocity effects on pilot scale bag filter, dust collector performance are studied. Under insufficient can velocity, a large cleaning interval increase was observed. Cleaning interval and dust emission increased by lowered inlet particle concentration. Above increasing tendencies deviated from expected theoretical tendency. Types of bags and their design temperature. What is the minimum air-to-cloth ratio for bag filter? The air-to-cloth ratio is typically between 1.5 and 3.5 meters per minute, mainly depending on the concentration of dust loading. Types of bags. Polyester bag. 90 degrees Celsius. Rhyton bags. 180 degrees Celsius. Mixed felt bag. 350 degrees Celsius. Filter fabric selection. Below is a table showing the properties of the materials used in the manufacture of the bags. How to choose the right bag for your application. The success in achieving high filtration efficiency for specific filtration process depends mainly on the success of choosing the suitable filter bags for your application from many perspectives such as 1. Working conditions. 2. The type of fabric, filter media. 3. The design of the bags, cages and cell plate. 4. The installation method of bags, together with the cages. 5. Type of yarn, fibers. 6. Fabric weave. Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information, by subscribe to the membership, and inviting your colleagues to watch this channel.